Most of us grow up with the quiet assumption that everything must have a centre. A room has a middle, a circle does. A spinning object feels balanced only when its mass gathers around a point. So it feels natural to imagine the universe the same way, organise around some hidden place where everything begins and everything matters most. Welcome to AstraFlow. Here, science drifts like starlight, and curiosity becomes calm. Tonight, let your thoughts slow down, your breathing soften, and your mind settle into quiet understanding. If you're listening from somewhere familiar or somewhere far from home, you're invited to share that in the comments. And if these long, steady explorations help you rest, you can support the channel simply by staying with us, listening, returning, letting the rhythm continue. Now, let's begin and explore the science of at the centre of everything, what NASA discovered. The idea of a centre feels deeply intuitive because it works so well in daily life. When you place an object on a table, you can find its midpoint. When you balance something in your hands, you feel where its weight gathers. Even our own bodies have a sense of orientation, of left and right, up and down, inside and out. This instinct carries with us as we look outward. We imagine Earth as a reference point, then the Sun, then perhaps the heart of our galaxy. Each step outward feels like it should lead closer to some ultimate middle, a cosmic anchor where everything began. For centuries, this expectation shaped how humans understood the universe. Early models placed Earth at the centre not because of arrogance, but because it matched what the sky appeared to do. The stars rose and set, the sun crossed the sky, everything seemed to revolve around us. As instruments improved, that centre shifted. Earth moved aside for the sun. Later, the sun was revealed as one star among hundreds of billions. The centre moved again, not because the universe changed, but because measurement became more precise. NASA's role in this long story is not to declare meaning, but to measure carefully. It does not search for significance in a poetic sense. It observes light, motion, temperature, gravity, and from those quiet numbers, patterns begin to appear. What those patterns suggested again and again was something unexpected. Not a hidden location, not a privileged direction, not a place where the universe points inward. Instead, NASA's observations began to show consistency. No matter where instruments looked, the universe behaved the same way. Not identical in detail, but consistent in structure. Galaxies formed. Space expanded. Light arrived from all directions, carrying the same ancient information. This posed a gentle problem for the idea of a centre. If every direction looks similar, where would the middle be? If space expands everywhere at once, what point could claim priority? If the oldest light surrounds us completely, how could it be coming from a single place? These are not dramatic questions. They do not demand urgency or fear. They simply ask us to slow down and reconsider a familiar assumption. Perhaps the universe does not organise itself around a location. Perhaps it organises itself around relationships, between matter and energy, between space and time, between motion and balance. In the sections ahead, we will move carefully through the observations that led to this understanding. We will look at light that has travelled for billions of years, at measurements so precise they detect changes smaller than a fraction of a millimetre, at patterns that repeat calmly across unimaginable distances. There is no rush. There is no single point we are trying to reach, only a steady movement through what science has learned and what it quietly set aside. When we talk about centres in everyday life, we usually mean something very practical. The centre of a room helps us arrange furniture. The centre of a wheel allows it to spin smoothly. The centre of mass tells us whether an object will balance or fall. These kinds of centres are useful because they describe how matter behaves under gravity and motion. They are not philosophical ideas. They are physical conveniences, ways of summarising how weight and force are distributed. If you hold a book flat on your hand, it feels stable when your hand is beneath its center of mass. Move your hand slightly away, and the book tilts. Nothing about the book itself has changed. Only the relationship between its mass and gravity. This experience teaches the brain something early on. Balance depends on centers. Stability feels central. So we begin to expect that larger systems must work the same way. When we look at the Earth, this expectation still works. Our planet has a center of mass deep beneath our feet. Gravity pulls everything toward it. Mountains, oceans, and atmosphere all respond to that central pull. The Moon orbits Earth around a shared center of mass. Earth orbits the Sun the same way. The Sun itself moves around the center of mass of the solar system, influenced slightly by the giant planets like Jupiter. At this scale, the idea of a center remains useful and accurate. It allows us to calculate orbits, predict tides, and send spacecraft where we intend them to go. NASA relies on these calculations every day. Because this idea works so well locally, it feels natural to extend it outward. If planets have centers, perhaps solar systems do too. If solar systems do, perhaps galaxies must have one central point that matters more than all others. And galaxies do have dense cores, regions where stars are packed closely together, where gravity dominates motion, where supermassive black holes often reside. But even here, something subtle begins to change. A galactic center is not a universal reference point. It governs motion within that galaxy, but it does not tell other galaxies how to move. It does not organize the universe beyond its own boundaries. As astronomers observed more galaxies, they noticed a pattern. Every galaxy seems to have its own center. None of them appears to be special when viewed from far away. No galaxy sits at the crossroads of cosmic motion. This is the first quiet hint that the idea of a single universal center may not apply at larger scales. What works for objects and planets does not automatically work for the universe itself. The brain resists this at first. It prefers continuity. It wants rules that scale smoothly from small to large. But nature does not always cooperate with our preferences. As we move outward in scale from rooms to planets to galaxies, the usefulness of center begins to fade. Not because it is wrong, but because it becomes incomplete. It describes local balance, not cosmic structure. In the next section, we will gently stretch this idea further, from familiar centers to distances so large that even gravity begins to behave differently, and we will see where the concept finally starts to lose its grip. As we continue outward in scale, the idea of a center begins to change more noticeably. What felt solid and reliable at human and planetary distances becomes less clear as distances grow. Consider the solar system. We often picture the sun calmly fixed at the center, with planets circling around it in neat paths. But even this image is a simplification. In reality, the sun does not sit perfectly still. It moves slightly, pulled by the gravity of the planets, especially Jupiter and Saturn. The true center of the solar system is a shared balance point, called the barycenter, and it can even lie just outside the sun itself. This detail does not disrupt our daily lives, but it reveals something important. Even systems we think of as having a clear center are actually defined by relationships and motion. The center is not an object. It is a calculation. When we step up another level, to the scale of galaxies, this becomes even clearer. Our galaxy, the Milky Way, has a dense central region filled with stars, gas, and a supermassive black hole. Gravity there is intense, stars orbit quickly, energy is high. Yet this galactic center only matters to the Milky Way. From the perspective of another galaxy, billions of light years away, our galactic core is just another region among many. It does not pull on distant galaxies in any special way. It does not mark a universal midpoint. Astronomers discovered this not by philosophy but by careful observation. When NASA and other space agencies mapped the positions and motions of galaxies, they noticed something unexpected. Galaxies are not arranged around a single focal point. Instead, they are spread out in all directions, forming clusters, filaments, and vast empty regions called voids. No matter where telescopes looked, the distribution appeared statistically similar. There was structure, but no preference. Patterns, but no pivot. This is where the idea of scale becomes essential. Gravity dominates at small and medium distances. It binds planets, stars, and galaxies together. But at the larger scales, gravity no longer organizes everything into a single hierarchy. Instead, space itself becomes active. It stretches. It expands. This expansion was first noticed when astronomers observed that distant galaxies are moving away from us. The farther away a galaxy is, the faster it appears to be receding. At first, this looked like evidence that we might be near the centre of everything. But when scientists looked more carefully, they realised something subtle. Observers in other galaxies would see the same thing. From any location, distant galaxies move away in all directions. This means the expansion is not happening from a point in space. It is happening to space itself. An everyday analogy helps here, but only gently. Imagine dots drawn on the surface of a balloon. As the balloon inflates, every dot moves away from every other dot. No dot sits at the centre of the surface. The surface expands everywhere at once. In the universe, there is no balloon surface we can step outside of. There is no external space into which the universe expands. Space is all there is, and it is stretching uniformly. This realization quietly removes the need for a cosmic center. If every region of space experiences expansion in the same way, then no region is privileged. No location can claim to be closer to the beginning than any other. The universe does not seem to be organized around a place. It appears to be organized around behavior. In the next section, we will look at how NASA confirmed this picture using ancient light that has been travelling since the earliest moments of the universe, and how that light carries the same message in every direction. To test whether the universe truly has no preferred place, scientists needed something older than galaxies themselves. They needed a signal that came from a time before stars, before planets, before structure had fully formed. NASA found that signal in light. Not ordinary light, but a faint background glow that fills all of space. It is called the cosmic microwave background, often shortened to CMB. It is not emitted by any star or galaxy. It comes from a time when the universe itself was young. Roughly 380,000 years after the beginning of cosmic expansion, the universe cooled enough for atoms to form. Before that moment, space was filled with a hot, dense plasma that scattered light constantly. Photons could not travel freely. They were trapped in a fog of charged particles. When atoms finally formed, that fog cleared. Light was released in all directions at once. Those photons have been travelling ever since, stretched by the expansion of space until they now arrive as faint microwaves. This ancient light reaches us today from every direction in the sky. NASA's satellites were designed to measure it with extraordinary precision, not to create a picture for beauty, but to detect tiny variations in temperature, differences of only a few millionths of a degree. When those measurements were completed, something remarkable appeared. The cosmic microwave background looks almost the same in every direction. No matter where instruments pointed, the temperature was nearly identical. If the universe had a central location, this light would tell us. One direction would look different from another. There would be gradients. There would be asymmetry. But that is not what NASA observed. Instead, the CMB showed uniformity. The same ancient signal surrounds Earth completely, and this would be true no matter where the observer was located. This is a powerful result, even though it is quiet. It means there is no edge we are closer to. no center we are orbiting, no direction that leads back to a point of origin. The small temperature variations that do exist are important, but not in the way a center would be. They represent tiny differences in density in the early universe. Over billions of years, gravity amplified those differences, allowing matter to gather into galaxies and clusters. Structure formed, but it formed everywhere at once. Not from a hub, but from subtle imbalance. NASA's measurements confirmed something that theory had suggested for decades. The universe follows the same rules in every direction. Its earliest light carries no sign of a preferred location. This does not make the universe emptier. It makes it more consistent. We're not looking outward from a special place. We're looking outward from a typical place and finding the same story written across the sky. In the next section, we will explore what this means for the idea of beginnings themselves and why the Big Bang is often misunderstood as a point in space rather than a change in space. When people hear the phrase the Big Bang, it is easy to imagine a single point in space. A tiny dot, a location where everything began then exploded outward into empty surroundings. This image feels natural, but it is not what the science describes. NASA's observations, combined with decades of theoretical work, show that the Big Bang was not an explosion in space. It was an expansion of space. That difference is subtle, but essential. At the earliest moments we can describe, the universe was not sitting inside a larger void. There was no outside. There was no surrounding emptiness waiting to be filled. Space itself was extremely hot, dense and compact, everywhere at once. As time passed, space began to expand, not from a central location, but uniformly. Every region moved away from every other region as the fabric of space stretched. This is why the idea of a central point does not apply. If you rewind the expansion backward in time, everything becomes closer together, but there is no single place where it all gathers. Instead, the entire universe becomes smaller, denser, and hotter simultaneously. NASA's measurements of the cosmic microwave background support this picture. That ancient light does not come from one direction. It arrives evenly from all sides, telling us that the early universe looked much the same everywhere. If there were a central origin point, we would see a gradient in this light, a direction where the universe looked younger, a region closer to the beginning, but no such direction exists. This leads to an important shift in how we think about beginnings. The Big Bang marks the beginning of time as we understand it, not a location in space. Asking where it happened is like asking where yesterday is located. Time began everywhere. Space expanded everywhere. No coordinates can be assigned. This idea can feel unsettling at first. Our minds like places. They like maps and reference points. But the universe is not obligated to match those intuitions. NASA's role here is not to challenge comfort, but to clarify reality. By measuring light, motion, and temperature with care, it has shown that the universe does not privilege any location. Every observer, anywhere in the cosmos, would see distant galaxies moving away. Every observer would see the same ancient glow filling the sky. Every observer could claim, honestly, to be at the center, because no one truly is. In the next section, we will look at how this realization reshaped modern cosmology and why scientists now focus less on position and more on patterns and relationships. Once scientists accepted that the universe has no central location, their questions began to change. Instead of asking where everything is centered, they began asking how everything behaves. This shift may seem small, but it reshaped modern cosmology. If no point in space is special, then the laws of physics must apply the same way everywhere. Light should travel the same way. Gravity should follow the same rules. Matter and energy should interact consistently no matter where you are. NASA's observations strongly support this idea. Spacecraft, telescopes, and satellites measure the same physical behavior whether they are near Earth orbiting the Sun, or looking billions of light years away. This principle is sometimes called cosmic uniformity. It does not mean the universe looks identical in every detail. Galaxies vary, stars are born and die, structures form and dissolve, but statistically, at the larger scales, the universe follows the same patterns everywhere. This realization helps explain something that might otherwise seem strange. If there is no center, how do we define motion at all? What does it mean for a galaxy to be moving away? The answer is that motion in the expanding universe is relative. Galaxies are not flying through space away from a central explosion. They are mostly staying in place relative to their local surroundings, while the space between them stretches. NASA's measurements of distant galaxies show this clearly. The farther away a galaxy is, the faster it appears to recede. This relationship is precise and predictable. Importantly, it looks the same from every location. An observer in a distant galaxy would measure the same pattern. From their perspective, we would be moving away. This tells us that expansion is not about direction. It is about scale. As the universe grows older, distances increase. Light takes longer to travel. Regions once closed drift beyond each other's reach. There is calm in this idea. Nothing is being pushed from a source. Nothing is racing toward an edge. Space is simply unfolding. By letting go of the need for a center, scientists gained something more useful. A framework that describes the universe as a whole. One that does not depend on where you stand. In the next section, we will explore how this framework led to the concept of the observable universe, and why what we can see is limited not by location, but by time. As scientists shifted their focus from location to behavior, another idea became central to understanding the universe: limits. Not limits of space itself, but limits of what we can observe. The universe may be vast beyond imagination, possibly infinite, but our view of it is not. What we can see is shaped by time. Light does not travel instantly. It moves at a finite speed. This simple fact places a boundary on observation. When NASA points a telescope toward a distant galaxy, it is not seeing that galaxy as it is now. It is seeing the galaxy as it was when its light began the journey toward us. For nearby stars, that journey takes years. For distant galaxies, it takes billions of years. This creates what scientists call the observable universe. It is not the whole universe. It is the portion from which light has had enough time to reach us since cosmic expansion began. This boundary is sometimes misunderstood as an edge. It is not. There is no wall, no sudden cutoff, no physical barrier. Beyond the observable universe, space continues. Galaxies exist, events unfold, but their light has not arrived and may never arrive. As the universe expands, distant regions move away faster and faster. Some are receding so quickly that their light will never cross the expanding space between us. They are not hidden behind something. They are simply separated by time and motion. NASA's measurements help make this idea precise. By observing how quickly galaxies recede, scientists can calculate how far light can travel. This defines a horizon, not in space, but in time. Every observer has such a horizon. Wherever you are in the universe, you're surrounded by a sphere of visibility shaped by the age of the cosmos and the speed of light. That sphere is centered on you, not because you are special, but because observation always begins where the observer exists. This can sound like a return to centrality, but it is not. It is a practical definition, not a cosmic one. Each observer carries their own observable universe with them. There is something steady about this. No matter where you are, the rules remain the same. No one sees more simply because of where they stand. The universe does not give preference. It offers consistency. In the next section, we will look at how this idea further dissolves the notion of a single beginning point in space, and how time quietly replaces place as the main reference for cosmic history. As the idea of the observable universe settles in, Another shift follows naturally. If what we can see depends on time, then time becomes the main guide for understanding cosmic history. When we look out into space, we're also looking back. Nearby objects show us the recent universe. Distant objects show us the universe when it was much younger. NASA's deep space observations make this clear. Galaxies close to us tend to look mature and structured. They have well-defined shapes, older stars, and slower rates of formation. Farther away, galaxies appear smaller, more irregular, and more active. Stars are forming rapidly. Gas clouds are turbulent. Structure is still emerging. This does not mean those distant galaxies are actually younger today. They are just as old as the Milky Way. We're simply seeing them at an earlier stage in their history. This is why the universe often looks layered in time. The farther we look, the earlier the chapter we read, and because this happens in every direction, there is no direction that leads back to a place of origin. Instead, the past surrounds us. NASA's measurements of the cosmic microwave background complete this picture. That faint glow represents the earliest time light could travel freely. It forms a kind of time boundary, not a spatial one. Before that moment, the universe was opaque. Light could not move through it. Information could not travel in the way we understand today. So when we ask about the beginning, science answers in terms of time. Not where, but when. Not location, but a condition. The early universe was hot, dense, and uniform. As time passed, it cooled and expanded. Small variations grew, structure emerged. None of this required a center. It required only laws that applied everywhere, consistently, from the very start. This understanding helps explain why the universe looks so similar in all directions. Every region went through the same early stages. Every region cooled and expanded together. The universe did not unfold outward from a point. It unfolded forward through time. In the next section, we will return briefly to gravity, not as a force that creates a cosmic center, but as a local organizer that shapes structure within an otherwise centerless whole. Gravity is often the reason we expect the universe to have a center. It pulls inward, it gathers matter, it creates dense regions surrounded by emptier space. On small scales, gravity dominates. It brings gas together to form stars. It binds stars into galaxies. It keeps planets moving in steady orbits. NASA's observations show this clearly. Where matter is concentrated, gravity shapes motion. Things fall inward. Systems organize around local balance points. These local centers are real. They are measurable. They are essential for understanding how structures form and persist. But gravity has a limited reach. Its influence weakens with distance. At the larger scales, it does not pull the universe into a single structure. Instead, gravity competes with expansion. Within galaxies and clusters, gravity wins. Between distant clusters, expansion dominates. This balance explains why the universe has structure without a central anchor. Matter gathers locally, while space continues to stretch globally. Clusters form, filaments emerge, vast voids open between them. NASA's large-scale surveys reveal this cosmic web clearly. Galaxies trace long strands across space. These strands intersect at clusters. Between them are regions with very little matter. There is no hub where all filaments meet, no crossroads of everything. The pattern repeats again and again wherever we look. This tells us something important. The universe organizes itself through simple rules applied everywhere. Gravity pulls nearby matter together. Expansion separates distant regions. Neither process requires a center. They operate based on distance and time, not position. Even the most massive structures we know, enormous clusters containing thousands of galaxies, are not central in any universal sense. They are just the largest outcomes of local conditions. From far enough away, they look no more special than any other cluster. This can feel counterintuitive. We often associate size with importance, but in cosmology, scale does not grant privilege. Every region follows the same rules. Every structure emerges from the same principles. In the next section, we will explore how this idea applies to observers themselves, and why, from any point in the universe, it can feel as though everything is moving away from you. From any point in the universe, the view looks much the same. This is one of the most quietly surprising outcomes of modern cosmology. When astronomers first noticed that distant galaxies are moving away from us, it was tempting to think this meant we were near the centre of expansion. After all, everything seemed to be receding outward from our position. But NASA's measurements showed that this interpretation does not hold. If you were standing in a distant galaxy, far beyond the Milky Way, and you measured the motion of other galaxies around you, you would see the same pattern. Nearby galaxies would drift slowly. More distant ones would recede faster, in every direction. This is not because each observer is special. It is because expansion depends on distance, not direction. The universe does not expand from a point. It expands between points. Every region of space stretches in relation to every other region. So wherever you are, you naturally appear to be at the centre of your own observable surroundings. This idea can be difficult at first. Our intuition tells us that if everything is moving away from us, we must be at the middle. But that intuition is shaped by everyday experiences, where space itself is static. In the universe, space is dynamic. It changes with time. NASA's observations confirm this again and again. The same expansion pattern appears no matter where telescopes are pointed. No direction shows slower or faster expansion overall. No region appears favoured. This leads to a calm but profound conclusion. There is no absolute viewpoint in the universe. No universal reference frame that stands still while everything else moves. Motion is always relative. Position is always local. This does not make observation meaningless. It makes it universal. Every observer has equal access to the same underlying behaviour of the cosmos. There is something stabilising in this idea. The universe does not revolve around us, but it also does not exclude us. We are not off to the side looking in. We are within the pattern, like everything else. In the next section, we will look more closely at what NASA actually concluded from all this data, not as a single discovery, but as a consistent message repeated across many missions and measurements. When NASA reviews decades of observations, there is no single moment where everything suddenly becomes clear. There is no announcement of a hidden centre uncovered or a final answer revealed. Instead, there is repetition. Different missions, different instruments, different kinds of data, all pointing quietly in the same direction. Space telescopes measuring distant galaxies, satellites mapping ancient radiation, probes tracking motion with extraordinary precision. Again and again, the results agree. No matter where scientists look, the universe behaves the same way on the larger scales. There is structure, but no hierarchy of places. There is motion, but no preferred direction. There is history, but no central location where it began. This is what NASA truly discovered at the centre of everything. Not an object, not a place, but a pattern. A universe governed by laws that do not depend on where you are. A cosmos that unfolds evenly, without a focal point. This understanding did not arrive all at once. It emerged slowly as measurements improved and theories were tested against reality. Each new mission added clarity rather than contradiction. When data did not fit expectations, the expectations changed. Centres were removed, special positions were abandoned. What remained was consistency. This is one of the strengths of science. It does not protect familiar ideas, it protects accurate ones. NASA's role in this process is careful and methodical. It measures first, it compares, it waits. Only then does it allow conclusions to form. The conclusion repeated across decades, is calm and stable. The universe does not organize itself around a point. It organizes itself around relationships between space, time, matter, and energy. This does not make the universe empty or indifferent. It makes it coherent. In the next section, we will explore what this coherence means for how cosmologists model the universe, and why focusing on patterns has proven far more powerful than searching for a center. As cosmologists adjusted to a universe without a center, the way they modeled reality began to change as well. Instead of drawing diagrams with a middle and edges, they started working with equations that describe behavior everywhere at once. These models do not ask where something happens. They ask how things change with time. NASA's data fits naturally into this approach. When scientists build cosmological models today, they assume that on large scales the universe is uniform and consistent. This assumption is not philosophical. It is practical. It matches what telescopes actually see. When the same statistical patterns appear in every direction, the simplest explanation is that the same rules apply everywhere. This shift has made predictions far more reliable. Models based on uniform laws can explain the expansion rate of the universe, the distribution of galaxies, and the faint temperature patterns in ancient light. None of these successes require a central location. In fact, introducing a center would complicate the equations and contradict observation. One of the quiet strengths of this approach is that it removes the need for cosmic privilege. No region must be treated as special. No adjustment is needed for where the observer happens to be. The universe can be described from any point, using the same framework. NASA's missions benefit directly from this. Spacecraft navigation, telescope calibration, and data interpretation all rely on predictable physical behavior. When a satellite measures radiation or motion, scientists do not need to ask whether its position makes the data less valid. The laws are the same. This consistency also helps explain why the universe can be studied at all. If physics changed from place to place, patterns would be impossible to recognize. Knowledge would fragment. Instead, regularity allows understanding to build slowly and securely. In a sense, letting go of the idea of a center has made the universe easier to understand, not harder. By focusing on patterns instead of positions, cosmology became calmer, cleaner, and more stable. In the next section, we will return briefly to the idea of importance and examine why being central has never been a requirement for influence or meaning in physical systems. It is easy to associate centrality with importance. In everyday life, what sits at the center often feels essential, while what lies at the edges can seem secondary. This intuition quietly follows us when we think about the universe. If something were truly important, we expect it to be central. Physics does not support this expectation. Influence in the universe does not come from position. It comes from interaction. A star affects its surroundings not because it is centrally located, but because of its mass, its energy output, and its distance from other objects. A galaxy shapes motion within it through gravity, not through symbolic placement. NASA's observations reinforce this again and again. Some of the most influential regions in the universe are not central at all. Exploding stars enrich surrounding space with heavy elements. Colliding galaxies trigger waves of star formation. Dense clusters bend light through gravity, revealing the presence of unseen matter. None of these processes depend on being at a universal midpoint. Even the early universe demonstrates this principle. The tiny variations that eventually grew into galaxies were not centered. They were scattered everywhere. Small differences amplified over time by gravity. Importance emerged from interaction, not location. This reframing is subtle, but it changes how we think about scale and relevance. The universe does not reserve significance for a particular place. It distributes influence through relationships. What matters is how things connect, exchange energy and evolve together. There is something quietly reassuring in this. Nothing must compete to be central. Nothing is diminished by being elsewhere. Every region participates equally in the unfolding of the cosmos. In the next section, we will gently return to the human perspective and look at how this understanding reshapes our sense of place, without adding philosophy or meaning beyond what the science itself supports. When science removes the idea of a universal centre, it does not remove our place in the universe. It simply changes how that place is described. We are not located at a special position, but we are located at a meaningful one. Meaningful because it is where observation happens. Every measurement NASA makes begins somewhere specific. A telescope orbits Earth. A probe travels past a planet. A satellite drifts through space. Each has a position, a velocity, a moment in time. From that local starting point, data is gathered and compared with data from elsewhere. What makes this powerful is not where the measurement is taken, but that it can be related to all others using the same physical rules. Observations from different locations fit together because the universe behaves consistently. There is no need to correct for cosmic favoritism. This consistency allows scientists to translate local observations into global understanding. Light detected here can be compared with light detected far away. Motion measured now can be related to motion measured billions of years ago. The lack of a centre makes these connections cleaner, not weaker. From a human perspective, this means our location is not diminished by being ordinary. We are not observers on the edge, nor residents of a hub. We are participants within a system that treats all locations the same. NASA's discoveries do not suggest that nothing matters. They suggest that what matters is not where you are, but how the universe behaves through time. The story is written in change, not in coordinates. This understanding encourages a quieter view of our surroundings. The night sky is not arranged around us, but it is readable from where we stand. The same patterns we observe here are visible in principle from any other galaxy. In the next section, we will look more closely at time itself, not as a ticking clock, but as the dimension that quietly holds the universe together when space offers no centre at all. Time becomes especially important once we let go of a central place. Without a fixed location to anchor the universe, time quietly takes on that role instead. Not as a point to aim for, but as a shared direction that everything follows. In cosmology, time is what allows events to be ordered. It tells us which processes came first, which followed, and how change unfolds. NASA's observations consistently rely on this ordering. Light arriving at a telescope carries information not about where something is now, but about when that light was emitted. Every observation is a message from the past. This is why the universe can feel layered. Nearby stars show us recent history. Distant galaxies show us earlier chapters. The cosmic microwave background shows us the universe near the beginning of transparency, when light first began to move freely. These layers are not stacked in space, they are stacked in time. Once this is understood, the absence of a centre feels less disorienting. The universe is not organised around a place, it is organised around a timeline. All regions move forward together even as they move apart. NASA's data supports this picture with remarkable consistency. No matter where scientists look, they find the same sequence: hot, dense beginnings, gradual cooling, the formation of atoms, the birth of stars, the growth of galaxies, the slow evolution of structure. The order may differ slightly in detail, but the progression remains the same. This shared timeline is what makes cosmology possible. If different regions followed different histories, comparison would be meaningless. But because time flows uniformly across space, patterns can be recognized and tested. It is also why the idea of earlier makes sense in every direction. When we look far away, we do not look toward a place of origin. We look toward an earlier state of the same universe. The past is not behind us in space. It is behind us in time. This replaces the need for a central origin point. Instead of asking where everything started, cosmology asks under what conditions it began. High temperature, high density, rapid expansion, those conditions applied everywhere at once. NASA's measurements are careful to respect this distinction. Instruments are calibrated not to find spatial landmarks, but to measure change. Redshift tells us how much space has expanded. Temperature fluctuations tell us how matter was distributed early on. Motion tells us how structures evolved. None of these require a center. All of them require time. There is a steadiness in this view. The universe is not drifting aimlessly without a middle. It is unfolding consistently along a shared timeline. Every galaxy, every star, every particle follows that same forward motion. In the next section, we will look at how this steady unfolding affects the future of the universe, and why even that future does not point toward a final center or destination, but toward continued change. Once we understand that time, rather than place, holds the universe together, it becomes easier to think about the future as well. Just as there was no central location at the beginning, there is no final destination toward which everything is moving. The universe is not heading for a point, it is continuing a process. NASA's observations show that cosmic expansion has not slowed to a stop. Over time, it has gradually accelerated. Galaxies that are already far apart are becoming even more separated. Light from distant regions takes longer and longer to reach us, until eventually some regions pass beyond our observable horizon. This does not mean the universe is breaking apart in a dramatic way. Locally, gravity continues to bind stars into galaxies and galaxies into clusters. These structures remain stable over immense spans of time. What changes is the relationship between very distant regions. Space between them stretches faster than light can cross it. Because there is no center, this expansion looks the same from everywhere. No galaxy sits closer to the future than another. No region advances faster through cosmic time. The unfolding remains uniform, even as distances grow. This has led scientists to think of the universe less as an object and more as a history, a sequence of states connected by physical laws. Early conditions lead naturally to later ones, without requiring guidance from a central point. NASA's long-term missions are designed with this continuity in mind. Measurements taken today are compared with those from decades ago. Future missions will extend these records not to search for a final answer, but to refine our understanding of how change proceeds. In this view, the universe does not move toward completion, it evolves. Structures form, persist, and eventually fade. Stars burn their fuel. Galaxies slowly alter their shapes. New generations of objects appear as others disappear. None of this is centered. All of it is connected. There is something quietly stabilizing in knowing that the future of the universe does not depend on reaching a specific place. It depends on following the same rules that have applied since the earliest times. Rules that do not shift with position, only with time. In the next section, we'll step back slightly and consider how this understanding influences the way scientists talk about the universe as a whole, and why language about centers persists even when the science no longer supports it. Even though modern cosmology no longer supports the idea of a universal center, the language of centers still appears often when people talk about the universe. This is partly because language lags behind understanding. Words that worked well for smaller systems are carried forward, even when their meaning begins to blur at larger scales. When scientists refer to the center of a galaxy, they're using a local and practical term. It describes a region of higher density and stronger gravity, not a place of cosmic importance. Problems arise when this language is extended too far, when a local description is mistaken for a universal one. NASA is careful about this distinction. In scientific papers and mission data, the focus is rarely on labels like center or edge. Instead, descriptions rely on measurable quantities: distance, mass, velocity, temperature, time. These are the variables that behave consistently and can be tested. Still, for communication, simpler words are often used. Saying the centre of the galaxy is easier than saying the region of maximum stellar density near the galactic core. Over time, these shortcuts can quietly shape expectations, especially outside scientific contexts. This is why the idea of a centre feels so persistent. It is familiar, it feels grounding. But familiarity does not make it accurate at all scales. The universe does not owe us intuitive symmetry. What NASA's discoveries encourage is a gentle correction, not a dramatic rejection. Centers exist where they are useful. They describe balance within systems. But beyond those systems, the universe is better understood as a network of relationships unfolding over time. Once this is accepted, much confusion falls away. Questions about where the universe began, or where it is heading, become questions about conditions and processes instead. The focus shifts from places to patterns. In the next section, we will look at how this pattern-based view helps scientists compare our universe to possible others, and why the absence of a centre actually makes such comparisons clearer, not more speculative. Thinking in terms of patterns rather than places also allows cosmologists to compare different possible universes in a meaningful way. When models are built around central points, comparisons become awkward. Each model must define its own special location. Results depend on perspective, but when models are based on uniform laws and shared behaviour, comparison becomes simpler. NASA's data plays an important role here. By measuring how our universe expands, how matter clumps and how radiation behaves, scientists can describe its overall character without referencing a centre. These descriptions can then be adjusted slightly to explore alternatives, a universe that expands faster, one that expands more slowly, one with different proportions of matter and energy. In these comparisons, location does not matter, only relationships do. How does expansion change with time? How does gravity shape structure? How does light travel through evolving space? These questions can be asked consistently across many models. This is one reason why the absence of a centre is not a limitation. It is a simplification. It removes unnecessary complications and keeps attention on what can actually be tested. NASA's observations provide the grounding for this approach, anchoring abstract models to measured reality. It is also why discussions of multiple universes, when they occur, focus on physical parameters rather than positions. Even if other universes exist, science would describe them by their behaviour, not by where they are relative to us. Where loses meaning when space itself is part of what differs. This reinforces the idea that our universe is best understood as a set of evolving conditions. Temperature changes, density changes, expansion rates change, but the laws governing those changes remain steady. By framing cosmology this way, scientists avoid turning the universe into a map with a marked centre. Instead, it becomes a timeline with measurable features. NASA's role is to trace that timeline as accurately as possible, using light that has travelled vast distances and instruments that can detect the smallest variations. In the next section, we will bring this back to a simpler scale and look at why, despite everything we've discussed, the idea of a centre still feels emotionally compelling, even when the science gently moves beyond it. Even after understanding the science, the idea of a centre can still feel emotionally important. This is not a flaw in reasoning. It is a reflection of how human perception evolved. We navigate the world by orienting ourselves. We look for middles, anchors, and reference points because they help us act and survive. Our senses are built for local environments. We stand somewhere, we look outward. From that position, everything appears arranged around us. This is not arrogance, it is geometry. Every observer naturally experiences the world from their own point of view. When this perspective is extended to the universe, the feeling remains. The sky arches overhead, Objects appear to surround us. Motion seems to radiate outward. Without careful measurement, it is easy to mistake perspective for structure. NASA's work helps separate these two. It does not deny the reality of perspective. It explains it. The reason the universe looks centered on us is the same reason a horizon forms around anyone standing on Earth. Observation always forms a sphere around the observer, shaped by distance and time, not by importance. Once this is understood, the emotional pull of centrality softens. We no longer need the universe to be arranged around us in order to feel oriented within it. Orientation comes from understanding, not from privilege. This is one of the quieter outcomes of modern cosmology. It does not remove meaning. It removes confusion. The universe is not ignoring us by lacking a center. It is treating every location the same way. In the next section, we will return briefly to Earth and consider how this cosmic understanding fits with the very local experience of living on a small, stable planet, moving calmly through a universe that has no central point at all. From the surface of Earth, the universe feels remarkably stable. The ground beneath us does not drift. The sky changes slowly. Day follows night with reliable rhythm. This local steadiness can make the larger picture of a centerless universe feel abstract or distant. NASA's perspective bridges that gap. Earth is not fixed in space, but it is part of several stable systems layered together. The planet rotates. It orbits the Sun. The solar system moves within the Milky Way. The galaxy itself travels through expanding space. Each motion is smooth, predictable, and governed by the same physical laws. These nested motions explain why daily life feels calm, even in a universe without a center. Stability does not require stillness. It requires balance. Local gravity provides that balance on Earth, just as it does within galaxies and clusters. From this viewpoint, the absence of a cosmic center does not translate into chaos. Instead, it allows many stable systems to exist at once, each one governed by local conditions, each one following global rules. Earth does not need to sit at the middle of everything to remain habitable. It needs only to follow the same laws as everything else. NASA's long-term measurements show that these laws are reliable. Planetary orbits remain steady. Stellar life cycles follow known patterns. Galactic structures evolve slowly. The universe may be vast and expanding, but it is not erratic. This consistency is what allows life, observation, and understanding to persist. A centerless universe can still be orderly. In fact, it may be orderly precisely because it does not revolve around a single point. In the next section, we will gently widen the view again and look at how this layered stability appears when we zoom out beyond galaxies toward the larger structures the universe contains. When we zoom out beyond individual galaxies, the universe reveals structure on scales that are difficult to picture. NASA's surveys show that galaxies are not scattered randomly. They trace vast patterns, forming clusters, superclusters, and long filaments that stretch across hundreds of millions of light years. Between these filaments lie enormous voids, regions where very little matter exists. At first glance, this web-like structure can seem as though it must converge somewhere. Filaments suggest connection. Clusters suggest gathering. It is tempting to imagine that if we could see far enough, all of these strands would lead to a single central region. But when scientists map these structures carefully, that convergence never appears. The patterns repeat. Filaments intersect at many points, not one. Voids appear everywhere, not just at the outskirts. No matter where the map is centered, the large-scale distribution looks statistically similar. This is another place where NASA's careful measurements matter. By surveying huge volumes of space, rather than focusing on a single direction, astronomers can test whether any region stands out. So far, none does. The cosmic web has no hub. What we see instead is a universe shaped by simple rules applied over immense time. Gravity pulls matter together locally. creating clusters and filaments. Expansion stretches space globally, separating these structures and opening voids between them. The result is order without a focal point. This kind of structure is not unique to the universe. Similar patterns appear in other systems driven by simple interactions, networks, fluids, even weather. Complexity emerges without a planner and without a center. Understanding this helps calm a lingering intuition. The universe does not need a central anchor to be organized. Its structure arises naturally from interaction and time. Every region participates in this process equally. In the next section, we will return once more to NASA's measurements and consider what it means that so many independent observations across different scales and methods all point toward the same quiet conclusion. One of the most reassuring aspects of this picture is how consistently it appears across different kinds of measurements. NASA has not reached its conclusions by relying on a single experiment or a single type of observation. The same message emerges whether scientists study light, motion, gravity, or temperature. Space telescopes observe the distribution of galaxies and see no preferred direction. Satellites measure ancient radiation and find the same signal everywhere. Probes track the motion of distant objects and confirm that expansion follows the same pattern, no matter where it is measured. Each dataset is collected independently, yet they align. This agreement matters. In science, when very different tools point toward the same conclusion, confidence grows. It suggests that the result is not an artifact of a particular method or a limitation of a single instrument. It reflects something fundamental about the universe itself. If a cosmic center existed, it would leave traces. Light would look different depending on direction. Motion would show asymmetries. Large-scale maps would reveal gradients or axes. NASA has looked carefully for these signs. So far, none have appeared. Instead, what appears is balance. Not balance in the sense of stillness, but balance in behavior. The universe expands the same way everywhere. The laws governing matter and energy remain constant. Local variations exist, but they sit atop a uniform foundation. This is why cosmology can be built gradually and securely. Each new mission does not overturn the previous picture. It refines it. Details become clearer, measurements become more precise. But the underlying framework remains steady. The absence of a center is not a gap in knowledge waiting to be filled. It is an outcome supported by many lines of evidence. NASA's discoveries do not leave us with uncertainty about where the center is. They show us that the question itself does not apply. In the next section, we will slow the pace further and consider how this understanding settles into a kind of continuity, allowing the mind to rest without needing a final point of reference. Once the idea of a center quietly fades, something else takes its place: continuity. The universe no longer feels like a structure arranged around a point, but like an ongoing process that does not need to aim anywhere in particular. It simply continues, moment by moment, following the same physical rules. This is where many people notice a subtle sense of calm. A universe without a center does not demand orientation. There is no need to locate yourself within a hierarchy. There is no correct direction to face. Everything unfolds evenly, without preference. NASA's observations reinforce this feeling of continuity. When scientists look across vast distances, they do not see abrupt changes in behavior. The same laws apply near and far, early and late. Differences appear gradually, shaped by time rather than position. This gradual change is important. It means the universe does not jump from one state to another. It transitions. Stars form slowly. Galaxies evolve over billions of years. Expansion alters distances steadily, not suddenly. Even the earliest moments we can observe show smooth patterns, not sharp breaks. Because of this, cosmology becomes less about finding endpoints and more about tracing flows: energy flows, matter flows, time flows. None of these require a center to move toward or away from. They simply proceed. This way of thinking can feel unfamiliar at first, especially if we're used to maps with marked middles and edges. But it matches what NASA continues to observe. The universe behaves like a system in motion, not an object arranged around a core. In the next section, we will begin the gentle transition toward closing, revisiting the opening idea of the center and seeing how it now appears, not as something missing, but as something we no longer need. At the beginning of this journey, the idea of a center felt natural and almost necessary. It seemed like a missing piece, something the universe must surely have, even if it was hidden from view. Now, after moving slowly through observation and evidence, that idea looks different. The center was never found because it was never required. What appeared to be a gap in understanding turned out to be an assumption carried over from smaller scales. Rooms have centers. Objects have centers. Even planets and galaxies have centers that are useful for describing motion. But the universe, taken as a whole, does not behave like an object within a larger space. NASA's discoveries did not remove something real. They removed a question that no longer fit the evidence. In its place, a clearer picture emerged, a universe defined by expansion, by consistent laws and by change unfolding through time. This shift is subtle. It does not announce itself loudly. There is no dramatic replacement for the missing center. Instead, there is a sense of completeness without it. The universe does not feel unfinished. It feels balanced in a different way. Understanding this allows earlier confusion to settle. There is no need to search for a point that everything revolves around. There is no need to imagine a direction that leads back to the beginning. The universe is not oriented that way. It is structured by relationships that exist everywhere at once. As this perspective becomes familiar, the mind can let go of the effort to locate itself within a cosmic map. There is nothing to aim for, nothing to align with, only a steady pattern that includes every location equally. In the next section, we will gently revisit how this understanding affects the way we think about ourselves within the universe, not by adding meaning, but by clarifying position and continuity. When we think about our place in the universe through this lens, it becomes quieter and more grounded. We are not positioned at a center, and we're not drifting at an edge. We exist at a point in space and time where observation is possible, where conditions allow matter to organize, and where understanding can slowly form. NASA's discoveries do not elevate or diminish this position, they simply describe it. Earth follows a stable orbit. The Sun follows a path through the galaxy. The galaxy moves within the expanding universe. Each layer is part of a larger motion, and none of these motions require a central reference point to make sense. What matters is that these motions are predictable. They follow laws that have not changed over billions of years. Because of that consistency, the universe becomes readable. We can trace where light came from. We can calculate how long it travelled. We can reconstruct events that occurred long before Earth existed. This is a different kind of orientation, not one based on where we are, but on how things change. The universe provides a timeline rather than a map with a marked centre. Understanding comes from following that timeline carefully, step by step. In this view, the absence of a centre is not a loss. It is a simplification. There is less to keep track of, fewer special cases to explain. The same principles apply everywhere, allowing knowledge to accumulate steadily. As this settles in, the idea of a centre no longer feels necessary. The universe does not need a focal point to be coherent. It needs only time, consistency, and connection. In the next section, we will begin the final widening of perspective, looking at how this steady, centerless universe continues forward, carrying all structures gently along with it. As the universe continues forward, it does so without gathering itself toward anything. There is no destination it is approaching, no place where all motion converges. What carries everything along is the same quiet process that has been unfolding since the earliest times, expansion guided by consistent laws. NASA's long-term observations suggest that this process is steady. Galaxies will continue to move apart on the larger scales, while remaining bound locally where gravity is strong enough. Stars will form and fade. Galaxies will slowly change their shapes. None of this requires a center to coordinate it. From this perspective, the future of the universe looks less like a journey toward a point and more like an ongoing continuation. Distances increase. Light takes longer to travel. Some regions drift beyond one another's reach. Yet the same physical rules apply everywhere, just as they always have. This is why predictions about the future focus on trends rather than endpoints. Scientists ask how fast expansion is changing, how structures respond over time, and how energy behaves as space grows. NASA's role is to measure these changes carefully, not to search for a final arrangement. The absence of a center simplifies these questions. There is no need to track where everything is relative to a special place. What matters is how relationships evolve, how far things are from one another, how those distances change, how time continues to pass. In a universe like this, continuity becomes the dominant theme. The future is connected to the past by the same laws applied everywhere. Nothing suddenly shifts direction. Nothing collapses toward a hidden middle. The unfolding remains smooth. As we move toward the closing sections, this understanding allows the mind to relax. There is nothing missing, nothing unresolved. The universe does not feel incomplete without a center. It feels open, consistent, and ongoing. In the next section, we will gently return to the language we use to describe the universe and see how, once the science is clear, that language can soften to match the calm structure it describes. With the science in place, the way we talk about the universe can begin to soften. Words like center, edge, and origin were useful stepping stones, but they no longer need to carry the weight they once did. NASA's discoveries invite a quieter vocabulary, one that reflects processes rather than positions. Instead of asking where things are centered, scientists describe how they change. Expansion rates replace directions. Density replaces hierarchy. Time replaces location. This shift is not about avoiding clarity. It is about matching language to what the universe actually does. When the language settles, confusion fades. There is no missing point to search for, no hidden axis to uncover. The universe does not conceal a center from us. It simply does not use one. Its structure is distributed, its behavior uniform, its history shared. This does not make explanations weaker, it makes them more precise. By removing unnecessary ideas, models become cleaner and predictions more reliable. NASA's data fits naturally into this streamlined view, reinforcing it with each new measurement. As listeners, we can allow our own language to slow down as well. We do not need to picture the universe as a diagram with a marked middle. We can picture it as a continuous unfolding, where every region participates equally. This perspective requires less effort to hold. There is nothing to locate, nothing to orient toward. Understanding becomes a matter of following patterns over time, not fixing attention on a single place. In the next section, we will begin to draw the narrative gently back toward a rest, revisiting the opening question one last time, and allowing it to resolve naturally. At the start, the question of a center carried a quiet tension. It felt like something important might be missing if we could not find it. Now, after moving carefully through observation and evidence, that tension has eased. The question has not been answered by pointing to a place, but by understanding why no such place is needed. NASA did not uncover a hidden middle. It uncovered consistency. The same physical laws apply everywhere. The same expansion unfolds in every direction. The same ancient light fills the sky from all sides. These findings do not leave a gap. They close one. This resolution is subtle. There is no dramatic moment where everything clicks into a single image. Instead, there is a gradual settling. The universe makes sense without a centre, and once that is accepted, it becomes difficult to imagine it any other way. What replaces the centre is not emptiness, it is connection. Distances relate to time, motion relates to scale, structure relates to interaction. These relationships form a stable framework that does not depend on position. From this view, the universe feels less like a puzzle missing a piece, and more like a system understood on its own terms. It does not resist interpretation. It simply asks that we let go of assumptions that no longer fit. As we move toward the final sections, the pace can slow further. The ideas no longer need to build. They can rest where they are, supported by what has already been observed and measured. In the next section, we'll begin the closing return, gently revisiting the opening idea and allowing it to dissolve into a quieter understanding. When we return to the opening idea now, it feels different. The question of a centre no longer carries uncertainty. It has softened into something simpler and more stable. We asked where everything is centred, and the answer turned out not to be a place at all, but a way the universe behaves. NASA's discoveries did not shift the universe away from a centre. They showed that the universe never relied on one. What holds everything together is not location, but continuity. Space expands, time moves forward, physical laws remain consistent. These features do not point inward, they apply everywhere. This understanding allows the mind to stop searching. There is no hidden coordinate to imagine, no distant region that matters more than the one you occupy. Every location follows the same rules, experiences the same unfolding, and shares the same history, stretching back to the earliest moments we can observe. Once this settles, the universe feels less demanding. It does not ask to be oriented around. It does not require us to find our place relative to a cosmic middle. It simply exists as a connected whole, unfolding evenly. This is not a loss of structure. It is a different kind of structure. One based on relationships rather than hierarchy, on change rather than position. The absence of a centre is not a gap. It is a feature of a universe that treats all regions equally. In the next section, we will allow this understanding to quiet further, shifting from explanation toward rest and preparing to bring the journey to a gentle close. As the explanations settle, what remains is a sense of calm continuity. The universe does not feel unfinished without a centre. It feels steady, governed by rules that do not change with location. NASA's measurements have shown this again and again, not through dramatic claims, but through patient confirmation. The absence of a centre removes a kind of tension we did not realise we were holding. There is no need to imagine a distant place that anchors everything else. There is no requirement to picture the universe as balanced around a hidden point. Balance comes from consistency, not from symmetry around location. In this view, the universe becomes easier to live with intellectually. It does not demand orientation. It does not ask us to find our position relative to a cosmic landmark. It simply unfolds, and we unfold with it, moment by moment, within the same framework that governs everything else. NASA's discoveries allow us to trust this framework. Light behaves the same way wherever it travels. Gravity follows the same patterns wherever it acts. Time orders events the same way everywhere. These shared behaviours create a kind of quiet reliability. When understanding reaches this stage, explanation can give way to rest. The ideas no longer need to be held tightly. They can remain in the background, stable and complete, without further effort. In the next section, we will begin the final return, easing fully into stillness, letting the question of the centre fade into the broader motion that carries everything gently forward. At this point, the question that guided us here no longer feels urgent. It has done its work. The idea of a centre helped open the discussion, and then slowly stepped aside as observation and evidence took its place. What remains is not an answer to hold on to, but an understanding that can rest quietly. The universe does not ask us to locate its middle. It asks only that we notice how it behaves. Space stretches, light travels, matter gathers and drifts apart. Time moves forward without pause. These motions are steady, predictable, and shared by everything that exists. NASA's discoveries did not add complexity for its own sake. They simplified the picture. By removing the need for a special place, the universe became easier to describe, easier to model, and easier to accept. Nothing is excluded. Nothing is favoured. Every region participates equally in the same unfolding. This understanding does not demand attention. It does not need to be revisited constantly. Like a stable rhythm, it can fade into the background while remaining reliable. The universe continues whether we think about it or not, guided by laws that do not require supervision. As this idea settles, the mind can loosen its grip. There is nothing left to resolve, no final location to imagine. The question has been answered not with a point, but with a pattern. In the next section, we will take the final step toward rest, allowing the motion of the universe to continue without explanation, and letting ourselves follow that motion into stillness. What remains now is motion without urgency. The universe continues to expand, not rushing toward anything, not pulling itself inward. It simply changes steadily and evenly, according to the same principles that have always applied. There is no center guiding this motion. There is only continuation. NASA's observations support this quiet picture. Measurements taken years apart align. Patterns traced across billions of light-years repeat. Nothing sudden appears. Nothing collapses toward a focal point. The universe behaves like a system that does not need correction. This steadiness allows the mind to relax into the idea. A centerless universe is not drifting. It is not disordered. It is balanced in a different way, through consistency rather than symmetry. Every region follows the same rules. Every moment follows the one before it. When this is understood, the question of where we are becomes less important than the fact that we are here at all, experiencing a universe that can be understood through observation and patience. Understanding does not require a destination. It requires attention and then release. NASA's work does not point us toward a final answer to hold on to. It points us toward a framework that continues to work. A universe without a center is not missing anything. It is complete in its own structure. From here, the explanations can slow to a stop. The ideas no longer need to be developed. They can remain as they are, stable and sufficient, allowing the mind to drift. In the next section, we will gently widen the view one last time, not to add new information, but to let the understanding settle into a broader sense of continuity. When we widen the view one last time, nothing new needs to be added. The universe does not suddenly reveal another layer or a hidden structure. What it offers instead is scale. Not as something to analyze, but as something that remains steady whether we pay attention to it or not. The same expansion that separates distant galaxies has been unfolding for billions of years, long before there were observers to notice it. The same laws that guide stars through their life cycles will continue long after any single system changes. This continuity does not depend on awareness. It does not pause. It does not accelerate for significance. NASA's observations remind us of this gently. Every measurement fits into a larger timeline. Every discovery aligns with patterns already present. The universe does not reinvent itself. It continues. In this wider perspective, the absence of a center feels natural. Large systems rarely revolve around a single point. They evolve through interaction and time. The universe is no different. Its stability comes from repetition, not from anchoring itself to a place. This allows a subtle shift in attention. Instead of looking inward for a middle, awareness can spread outward evenly. There is no preferred direction, no location that needs to be held in mind. The universe does not require orientation. As this understanding settles, the mind can mirror the universe's behavior. It does not need to fix itself around a thought. It can move gently, without focus, without effort, letting ideas pass as space itself allows distances to grow. In the next section, we will begin the closing return, bringing the journey quietly back toward rest, without introducing anything new. As the journey begins to close, the pace naturally slows. There is no final concept to introduce, no new structure to examine. Everything that needed to be said has already been placed gently in order. What remains is simply to let it settle. The universe does not conclude, it continues. Expansion does not stop to mark an ending. Time does not pause to signal completion. In the same way, understanding does not need a final thought to be complete. It can rest in what is already known. NASA's discoveries leave us with this quiet stability. Not answers that demand attention, but patterns that remain reliable, whether we focus on them or not. The universe behaves the same way in every direction, at every location, across immense spans of time. There is comfort in this consistency. Nothing sudden waits ahead. Nothing essential has been missed. The absence of a center does not leave the universe unbalanced. It allows everything to exist without competition, without hierarchy, without pressure to be more central than something else. As attention softens, it becomes easier to let thoughts drift without following them. Just as space stretches evenly, awareness can spread without effort. There is no need to hold a point in mind. Nothing needs to be anchored. In the next section, we will gently return to the opening theme one last time, not to repeat it, but to let it dissolve fully into the calm continuity that has been with us all along. At the beginning, the idea of a center felt like a question waiting for an answer. It gave the mind something to search for, something to orient around. Now, as we return to it gently, that question no longer asks to be solved. It has softened into understanding. There is no single place that holds everything together. What holds the universe together is repetition. The same laws applied everywhere. The same unfolding, experienced by every region of space. NASA's observations did not replace the center with another object or idea. They showed that nothing needs to take its place. This realization does not remove structure. It reveals a deeper one. A structure based on continuity rather than position, on behavior rather than location, on time rather than coordinates. Once this is seen, the need to search fades naturally. There is nothing hidden just out of reach, nothing waiting at the middle. The universe is already complete in the way it behaves. This can feel surprisingly restful. Questions resolve not by being answered directly, but by becoming unnecessary. The mind can release them without effort. In the next section, we will continue this return, letting the idea of the center fade fully into the background, leaving only motion, consistency, and quiet continuity. As the idea of a center fades into the background, what remains is a steady sense of flow. The universe does not pause to define itself around a point. It continues in the same way it always has, guided by laws that do not depend on location. Expansion proceeds, time advances, structures form and slowly change. Nothing needs to be held in place for this to happen. NASA's discoveries fit comfortably into this view. They do not point toward a hidden anchor or a final reference. They describe a universe that is self-consistent, where every region follows the same rules and no position carries extra weight. This consistency is not dramatic. It is quiet, dependable, and persistent. When understanding reaches this stage, it no longer needs to be actively maintained. Like a stable orbit, it continues without effort. The mind does not need to circle a thought or return to a question. The explanation has settled into something simpler than an answer. It has become a background condition. In this calm framework, the universe feels less like something to solve and more like something to rest within. There is no urgency to locate yourself, no need to imagine where everything leads. The unfolding is already complete in its own way, moment by moment. In the next section, we will allow this flow to slow even further, preparing gently for the final return into rest, where nothing more needs to be understood. With the flow established, there is no need to push the understanding any further. The universe does not ask to be grasped tightly. It continues whether or not we attend to it, unfolding through time with a steadiness that does not depend on explanation. NASA's measurements simply confirm what this steadiness looks like when observed carefully. Across immense distances, the same patterns persist. Expansion continues. Local structures remain bound where gravity is strong enough. Light travels, carrying information forward from earlier moments to later ones. None of this requires a central reference. It proceeds because the conditions that allow it are present everywhere. This is where scale becomes gentle rather than overwhelming. The universe is vast, but it is not chaotic. It is large, but it is not demanding. Its size does not require us to orient ourselves within it. It only requires that the same rules apply from place to place, moment to moment. When we stop looking for a centre, attention naturally spreads. There is no single point to focus on. Awareness can widen without effort, much like space itself expands without direction. Nothing needs to be held. Nothing needs to be resolved. NASA's work supports this calm view. It does not suggest instability or imbalance. It suggests continuity. The universe is not waiting to tip or collapse. It is moving along a path it has followed for billions of years, quietly and reliably. As this settles, the mind can mirror that behaviour. Thoughts can slow. Focus can soften. There is no final concept to reach. The understanding is already complete enough to rest on. In the next section, we will begin the final closing, allowing everything we've explored to settle fully into stillness, without adding anything more. As we approach the end, nothing new needs to be held in mind. The ideas have already settled into place, like distant objects that no longer require focus to remain visible. The universe continues as it always has, not centered on anything, not moving toward a final point, simply unfolding through time. NASA's discoveries leave us with this quiet assurance. The cosmos is not arranged around a middle that must be found or understood. It is arranged through consistent behaviour, repeated everywhere. Without preference, space expands, time advances, matter responds. These patterns do not depend on where you are. At this stage, explanation naturally gives way to presence. There is no puzzle left to solve, no conclusion to reach. The understanding does not need reinforcement. It can remain gently in the background, stable and complete. Just as the universe does not rush, there is no need to hurry here. The motion we have been describing is slow, even by cosmic standards. Expansion happens gradually. Change unfolds over immense spans. Nothing demands immediate attention. With that in mind, the focus can soften further. Thoughts can pass without being followed. Awareness can widen and then rest, without fixing on any particular idea or image. There is no centre to return to, and no edge to avoid. In the final sections, we will simply return to stillness, letting the steady motion of the universe continue on its own, while the mind is free to drift toward rest. We can return now gently to where we began, not to repeat the question, but to notice how it feels after everything has settled. At the start, the idea of a centre felt important. It seemed like something the universe ought to have, something that would make everything feel oriented and complete. Now, that need has eased. NASA's discoveries did not point us toward a hidden place. They guided us toward a quieter understanding. The universe does not gather itself around a point. It continues through time, evenly and consistently without preference. Nothing has been taken away. What changed was the frame we were using to look. Once that frame shifted, the picture became simpler, calmer, and more stable. There is no final location to imagine, no distant middle to hold in mind, only motion that does not rush and laws that do not vary from place to place. With that, the search can end. Not because an answer was found, but because the question no longer needs to be carried. In the next and final section, we will allow this understanding to fade completely into rest, letting the universe continue as it always has, while attention gently lets go. The universe moves on without pause, space stretches, time flows forward, structures form and slowly change, guided by the same rules everywhere. There is no center directing this motion, no point that everything depends on, only continuity, steady and unbroken. You are part of that motion, not separate from it, not central to it, simply within it. As thoughts slow, there is nothing left to hold, no place to imagine, no direction to follow. Everything flows. Sleep in that motion,